Types of generative AI models. Generative AI models are a fascinating and rapidly evolving field of artificial intelligence. These models have the ability to generate new and original content, such as images, text, or even music, based on the training data they have been exposed to. In this presentation, we will explore the different types of generative AI models and understand how they work. One of the most well-known types of generative AI models is the Generative Adversarial Network, GAN. GANs consist of two neural networks, a generator and a discriminator, that are trained in a competitive manner. The generator network tries to create realistic-looking outputs, while the discriminator network tries to distinguish between the generated outputs and real data. Through this adversarial training process, the generator network learns to produce increasingly convincing outputs that can fool the discriminator. Another type of generative AI model is the variational autoencoder, VAE. VAEs work by learning a compressed representation of the input data, called the latent space, and then using this latent space to generate new, similar-looking outputs. The model consists of an encoder network that maps the input data to the latent space and a decoder network that generates new outputs from the latent space. VAEs are particularly useful for tasks like image generation, where they can create new images that resemble the training data. Autoregressive models, such as transformers and recurrent neural networks (RNNs), are another type of generative AI model. These models generate new outputs by predicting the next element in a sequence based on the previous elements. For example, an autoregressive text generation model might predict the next word in a sentence given the previous words. Autoregressive models are widely used for tasks like language modeling, machine translation, and music generation. Diffusion models are a more recent type of generative AI model that have shown impressive results in image and audio generation. Diffusion models work by gradually adding noise to the input data and then learning to reverse this process to generate new, realistic-looking outputs. This approach allows diffusion models to capture the complex structure and patterns in the training data and generate highly detailed and diverse outputs. Finally, we have flow-based models, which are a type of generative AI model that learn a bijective transformation between the input data and a simple, known distribution, such as a Gaussian distribution. This allows flow-based models to generate new samples by simply sampling from the known distribution and applying the learned transformation. Flow-based models are particularly efficient and can be used for tasks like image generation and density estimation. In summary, the different types of generative AI models, including GANs, VAEs, autoregressive models, diffusion models, and flow-based models, each have their own unique strengths and applications. These models are revolutionizing the way we create and interact with digital content, and their continued development will undoubtedly lead to even more exciting and innovative applications in the future. To conclude, generative AI models are a powerful and versatile tool that are transforming the way we create and interact with digital content. By understanding the different types of generative AI models and how they work, we can better appreciate the potential of this technology and explore new and exciting applications. As the field of generative AI continues to evolve, we can look forward to even more impressive and innovative developments in the years to come.